Every spring, something extraordinary happens in the heart of California. 1.3 million honeybee hives arrive in the Central Valley. That is nearly half of all commercial bees in the United States of America. They are not here for tourism. They are here for the largest nut harvest on planet Earth, almonds. But the bees are only the beginning. The real shock comes weeks later, when a machine grabs a full-grown tree, shakes it with violent precision for exactly 1 second, and drops 200 pounds of nuts onto the dry earth. This is not small farming. This is not a backyard orchard. This is the industrial backbone of a multi-billion-dollar crop that supplies 80% of the world's almonds. Welcome to California's massive almond harvest, 1 billion nuts per day. To understand the scale, you have to start with the land. The Central Valley stretches over 450 miles from north to south. It is one of the most productive agricultural regions on the planet, and almond orchards cover more than 1.6 million acres here. That is an area larger than the state of Delaware. Each acre holds between 100 and 150 almond trees. Each tree, when mature, produces between 50 and 65 pounds of nuts. But none of this happens by accident. Let us go back to February, when the entire valley looks like a different world. The almond growing cycle begins in late winter, when the trees burst into bloom. For 2 weeks, the valley turns white and pink with nearly 50 billion flowers. The air smells sweet, almost perfumed, and the sound is unlike anything else in agriculture, a deep hypnotic hum that never stops. That is the sound of 1.3 million beehives at work. Each hive contains up to 60,000 bees. They move from blossom to blossom, collecting nectar and pollen, and in the process, they pollinate every potential nut. Without them, there are no almonds. Growers pay beekeepers hundreds of dollars per hive. It is the largest managed pollination event on Earth. For the farmer, this is the most stressful time of the year. A single storm can destroy the bloom. A freeze can kill the flowers. Wind can dry out the pollen before it ever reaches the stigma. But when everything aligns, when the weather holds and the bees work, the tiny green nuts begin to form. From March through June, those tiny green nuts grow slowly inside a soft, leathery outer hull. Under that hull is a hard, woody shell. And inside that shell is the almond kernel, the part we eat. The trees are thirsty during these months. They need water constantly. But this is not flood irrigation anymore. Most orchards now use micro sprinkler systems and low-level drip lines that run continuously along the rows of trees. Water drips directly onto the root zone, drop by drop. Some advanced farms go even further. They install soil moisture sensors at different depths. Probes send data wirelessly to a central computer. The computer analyzes evapotranspiration rates, weather forecasts, and soil conditions. Then it opens and closes valves automatically, delivering exactly the right amount of water to each section of the orchard. This is precision agriculture on a massive scale. Drones fly overhead every week. They carry multispectral cameras that capture images invisible to the human eye. These images reveal which parts of the orchard are stressed by lack of water, by disease, or by insect damage. A farmer can spot a problem before it becomes visible from the ground. They can send a sprayer to exactly 1 acre instead of spraying the whole orchard. This is not science fiction. This is happening right now in California. And through the summer, the nuts mature. The hulls begin to split open. The shells harden. By early August, the almonds are ready. And then the quiet ends. The harvest does not happen all at once, and it does not happen by hand. The first step is called sweeping, but before the sweeper arrives, something else has to happen. The orchard floor must be clean. A specialized tractor rolls through the orchard, pulling a massive rotary mower. It cuts the cover crop and weeds that have grown between the rows. The mower blades spin at high speed, chopping everything into small pieces. Behind the tractor, the ground is smooth and bare. This is essential because in a few weeks, the nuts will fall onto this ground, and you do not want them landing on rocks or clumps of dirt. Then comes the sweeper. This machine looks like a giant street sweeper, but instead of cleaning cities, it cleans orchards. A rotating broom head spins at the front, brushing the nuts gently into the center of the row. Behind the broom, a series of belts and augers moves the nuts into neat continuous rows called windrows. The sweeper works at roughly 5 miles per hour, covering acres every hour. From a drone's perspective, you see perfect brown lines running through the orchard, straight as arrows stretching to the horizon. Behind the sweeper, the row of nuts sits perfectly aligned, waiting for the next machine. And then comes the machine everyone waits for, the tree shaker. This is not a gentle device. It is a powerful hydraulic monster mounted on the front of a heavy-duty tractor. The tractor itself weighs nearly 30,000 pounds. The shaker arm extends out to the side. At the end of the arm is a large clamping head with padded grips. The driver maneuvers the tractor until the clamp surrounds the trunk of the tree. Then hydraulic pressure builds. The clamp closes with enormous force, but the pads protect the bark. The shaker mechanism engages. The frequency is precisely calibrated. Too slow and the nuts will not fall. Too fast and the tree can split. The shaker operates at approximately 20 cycles per second. For 1 second, the tree convulses violently. The trunk bends. The branches whip back and forth. The entire tree shakes like a dog coming out of water. And then, like a brown waterfall, the almonds rain down. The sound is a deep, bass, heavy thud that echoes across the valley. Workers wear ear protection. The ground vibrates under your feet. Dust rises in clouds. And within seconds, the tree is empty. Every single almond has fallen. The shaker releases the trunk, moves forward 20 feet and grabs the next tree, and the next, and the next. In one 10-hour shift, a single shaker can harvest 10 to 15 acres. Over the 6-week harvest window, hundreds of shakers work 14 hours a day, 7 days a week. The number of nuts falling in a single day is almost impossible to comprehend. Roughly 1 billion individual almonds hit the ground every 24 hours. Now the floor of the orchard becomes a carpet of nuts. They lie in thick rows, sometimes 3 to 4 inches deep. The next machine is the pickup. It is a large, self-propelled harvester that moves slowly through the orchard at about 2 miles per hour. At the front, a rotating brush and a series of conveyor belts lift the almonds from the ground. The brush sweeps the nuts onto a slatted belt. The belt carries them up into the machine. Inside, a powerful fan blows air across the falling nuts. The airspeed is carefully adjusted. The nuts, being heavy, drop straight down. The leaves, twigs, and dust, being light, blow away and out the back of the machine. You can see the dust cloud trailing behind the harvester for hundreds of feet. It looks like a brown fog drifting through the trees. The clean nuts fall into a hopper that can hold up to 2,000 pounds. When the hopper is full, the driver presses a button. A conveyor arm unfolds from the side of the harvester and extends over a trailer pulled alongside. The nuts pour out in a continuous stream. The sound is a steady rumble of millions of nuts sliding against metal. The driver never stops moving. The whole process, from the ground to the trailer, takes less than 60 seconds. A fleet of these trailers runs continuously, hauling almonds to the collection points. This is industrial efficiency at its most hypnotic. The rhythm is almost musical. Sweep, shake, pick up, unload. Repeat 10,000 times per day. The almonds are now in the trailer, but they are not yet ready for your kitchen. They still have their outer hulls. They still have their hard shells. They are dirty. They are mixed with rocks, sticks, and debris. They need to go to the processing plant. And not a small plant, a mega facility. The trucks haul the almonds to massive collection points known as sheller facilities. Some of these facilities are enormous, covering 30 acres or more. They operate 24 hours a day during harvest. The first stop is the receiving pit. The truck backs up to a below-grade hopper. The driver opens the gate, and the entire load of almonds falls into the pit in a roaring cascade. A drag chain conveyor at the bottom of the pit pulls the nuts up into the facility. From there, the almonds move through a preliminary cleaning system. Vibrating screens shake out rocks and large debris. Magnets catch any stray metal. An air knife blows off light material. What remains is almonds and hulls. Then they enter the huller. This machine uses rotating cylinders with abrasive surfaces. The cylinders spin at different speeds, twisting and tearing the leathery outer hull away from the shell. The hulls exit through one port and are blown into large bins. Nothing is wasted. These hulls are sold as cattle feed. Dairy farms across California buy them by the thousands of tons. The nuts now, still in their hard shells, move to the sheller. This machine is a marvel of engineering. It cracks the hard shell without damaging the delicate kernel inside. Inside the sheller, rotating discs create centrifugal force. The nuts are thrown against impact surfaces. The shells crack open, but the kernels remain intact. It is a delicate balance of speed, impact angle, and clearance. Too much force and the kernel breaks. Too little and the shell stays closed. The shells are lighter than the kernels. A stream of air blows them away. The kernels drop down. The shells go to another bin, where they are sold as bedding for animals or as fuel for biomass power plants. Again, nothing is wasted. But the process is not finished. The almonds now go through an optical sorting system. This is where the future arrives. High-speed cameras scan every single nut at a rate of thousands per minute. The cameras capture color, size, shape, and even surface texture. Artificial intelligence algorithms analyze each nut in milliseconds. If a nut is discolored, shriveled, damaged by insects, or has a piece of shell still attached, the computer identifies it instantly. A precise burst of compressed air, aimed by computer-controlled nozzles, blows that single nut into a rejection chute. Perfect nuts continue down the line. This happens so fast that the human eye cannot follow it. What you see is a steady, hypnotic stream of almonds moving under flashing lights. Occasionally, a few nuts fly sideways into the reject bin, but most of them continue, a perfect river of golden brown kernels. The reject rate is incredibly low. These machines can remove one bad nut out of 10,000. That is 99.99% accuracy. After sorting, the almonds are washed in a sanitizing solution to remove any remaining dust or surface bacteria. Then they pass through massive hot air tunnels that dry them to a precise moisture level. Too wet and they will mold in storage. Too dry and they will crack and lose flavor. The target moisture content is around 6%. The drying tunnels are long, sometimes 200 feet or more. The nuts travel slowly on perforated belts while hot air blows from above and below. By the time they exit, they are clean, dry, and ready for storage. Giant silos and climate-controlled warehouses hold millions of pounds of nuts at a constant temperature of 34 degrees Fahrenheit. Some almonds will be shipped raw in their natural state. Others will go to roasting lines. Inside the roasting facility, massive rotating drums tumble the almonds while hot air at 300 degrees Fahrenheit circulates around them. Some almonds are roasted dry. Others are coated with oil, salt, honey, or chocolate. The coating lines are mesmerizing. Almonds cascade down vibrating conveyors while spray nozzles apply liquid coatings. Then they tumble through seasoning drums where powder sticks to the wet surface. The colors change from natural brown to honey gold to dark chocolate. Some almonds are sliced. High-speed cutting machines use razor-thin blades to slice each almond into perfect slivers. The slivers fall onto shaker screens that separate them by thickness. Some are ground into almond flour. A hammer mill pulverizes the nuts into fine powder. The flour is sifted through mesh screens to ensure uniform particle size. And at the end of every line, robotic packers place the nuts into bags, boxes, or bulk containers. The robots move with inhuman speed and precision. They pick up empty bags, open them, fill them with exactly the right weight of almonds, seal them, and place them onto a conveyor. Palletizers, which are another type of robot, stack the finished products onto wooden pallets. They build the pallets in interlocking patterns to prevent tipping. Then they wrap the entire pallet in stretch plastic. The wrapped pallet moves to the loading dock. A forklift picks it up and places it into a waiting truck or shipping container. From there, trucks and trains carry California almonds to ports in Oakland and Los Angeles. And from those ports, ships carry them to every continent on Earth. Europe, Asia, the Middle East, Australia. California almonds are truly a global crop. But the story does not end at the factory door. The scale of the almond industry is staggering. California produces roughly 3 billion pounds of almonds every year. That is nearly 80% of the global supply. The industry supports more than 110,000 jobs, from beekeepers who haul hives across the country, to truck drivers who move the harvest, to machine operators who run the shakers, to food scientists who develop new almond products, to export coordinators who book ocean freight. The economic impact is more than $11 billion annually, and yet the average person has no idea how this hidden world operates. They see a bag of almonds at the grocery store. They do not see the 1.3 million beehives. They do not see the tree shaker that grabs a trunk and makes 1 billion nuts fall. They do not see the optical sorters that reject one bad nut out of 10,000. They do not see the conveyor belts moving at midnight under bright lights while the valley sleeps. They do not see the mountains of hulls being loaded into cattle trucks. They do not see the ships leaving the harbor with thousands of containers, each one filled with nuts that started as a flower, visited by a bee, shaken by a machine, sorted by a camera, and packed by a robot. The harvest window is only 6 weeks. When it ends, the trees begin to rest. The leaves turn yellow, then brown, then fall. The orchards look silver and quiet in the winter light. But the machines do not stop. Inside the Huller-Scheller facilities, the work continues 24 hours a day until every last nut is processed. By December, the almonds are in warehouses. By January, they are on ships. By February, they are arriving at ports around the world. And by spring, when the bees return to the blossoms for another season, the almonds from last year are already in your hands. You have eaten them as a snack. You have drunk them as almond milk. You have baked them into cookies. You have spread almond butter on your toast. And you have never known the journey. This is the hidden rhythm of industrial agriculture. It is loud, it is dusty, it is relentless, but it is also beautiful. Because underneath the noise and the machinery, there is something simple. A tree that grows from the soil, a nut that falls to the ground, a billion people who will eat it without ever knowing the journey it took. That is the wonder of the massive almond harvest. That is the hidden world that most eyes will never see, until now.